Now let's talk about object-oriented programming, OOP. Object-oriented programming, OOP, is a programming paradigm based on the concept of objects, which are data structures that contain data, in the form of attributes, and code, in the form of functions known as methods. A distinguished feature of object is that an object method can access and often modify the data attributes of the object with which they are associated. In OO programming, computer programs are designed by making them out of objects that interact with one another. So let's create our first class. I'm gonna create a new folder called OOP. There, I wanna create a new file called simples.class.py, and then I wanna say class simples, and then a pass. Okay. I wanna print type of simples. I can also say sim equal to simples, an instance of simples. I wanna print the type of sim. Okay. You can also say if print type of sim is equal to simples. Okay. Let's secure it. In this case, I wanna enter to OP simples, and let's start. So in the first print, you'll see the simples is a class, and also in line 6, we are printing the instance of simp, which is a simple class type. And the last one, we are comparing an instance of simp with a simple class, which is true or equal. Now let's talk about attribute shadowing. When you search for an attribute in an object, if it's not found, Python keeps searching it and the class that was used to create that object. This leads to an interesting shadowing behavior, so let's look at another example. Keep in mind that Python keeps searching until it's either found or the end of the inherit chain is reached. Let's see in one example, okay? Let's create a new file called, in this case, class attribute dot shadowing, okay, dot py. I want to say class point, which x is equal to 10, y is equal to 7. Okay, so let's print let's create an instance point. Let's create a new point. I wanna print p.x, p.y. Let's say p.x equal to 12. I wanna print p.x, okay, and also I wanna print point.x. Let's delete p.x. I wanna print it again. Print p.x, okay. Also I wanna say p.c equal to 3. Let's print p.c and finally print point dot z. Okay, so let's secure it. CLS. Let's see what we got here. Okay, first of all, when printing x and y, okay, we've got here 10 and 7. Then when printing px again, but we changed it before with the value 2. Then when printing point.x, which is 10, the original class. Okay. Then we were printing p.x, which is returning 10, but we deleted before, so this x that we got here is from the original class. Okay, point right here. And also we're printing 3, okay, pc z, which is assigning here, but we've got an error here because point has no attribute c. Now let's talk about me, myself, and I using self variable. From within the class methods, we can refer to an instance by means of a special argument called self by convention. Self is always the first attribute of an instance method. Let's examine this behavior together with how we can share not just attributes but methods with all instances. Okay, let's create a new file called class.self.py. Okay, class square side and also depth and area function which receive self. Okay, or in return self.side is self with f with a power of 2. So just below sq equal to square new square, and then let's print sq area and also a square area. Okay, but area of sq, and let's comment here that this side is found on the class, and here is equivalent to sq.area. Okay, then sq.area side equal to 10. Just print sq area, which side is found on the instance. Keep in mind here that self is a reference to an instance. Okay, let's execute it and see what we thought. Pi oh sorry, it's class self. Okay, we've got here 64, 64, and 100. And the first one, the side is found in the class, so 8 with a power of 2 is 64, Then we are calling square.area where we are passing this instance where side is equal to a again, which is equivalent practically. And finally, we are assigning execute side equal to 10. So the reason this change to 10. When we call area, we are evaluating 10 with a power of 2. What about if we create another file called class price.py? Let's say class price with a method called final price. And the first parameter we've got self, then but, then discount by default 0. Just duck here and say returns price after applying but and fixed discount. Okay, so return an operation here self dot net price times 100 plus but over 100, okay, minus discount. This operator. So let's execute it. Let's call p1 is equal to price p1 dot net price equal to 100. Let's print price dot final price with p1 a self 20 and 100 a 10, and then execute the same with p1. Okay, but in this case I don't need to send p1, just like this. Let's execute it class.price. You've got the same result. The preceding code shows you that nothing prevents us from using arguments when declaring methods. We can use the exact same syntax as we used with the function, but we need to remember that the first argument will always be the instance. We don't need to necessarily call it itself, but it's a convention, and this is one of the few cases where it's very important to abide by it.